a presentation on my project SecureSurf, a Chromium-based browser to protect user privacy and security. And so a major problem with high-end security tools is that they are too complicated for the average person to use. They require complex steps or terminal commands. And my main goal in this project was to make sure that it was accessible for all users to use. And I've done this by packaging the entire system into a .app file so that once the user downloads it, all they need to do is drag it to their applications folder. And you can see on the right here, this is my project SecureSurf, and it's on my laptop in the applications folder. So if I were to like double click on this icon, then the protected browser or my project will open up. And then I was thinking about my project versus other extension-based blockers, because there's a lot of those. And I wanted to make sure mine was like obviously better and working as effectively as possible. And doing some research on extension-based blockers, I found that those work when the user goes to a URL like Chrome, Safari, etc., and then the website's code is pulled from there and handed over to the extension. And this is actually not as effective because by the time the extension has read the code and identified that the site is unsafe, the browser has already made the initial connection to the tracker server, and the extension hides the ad after the page loads. So I wanted to block the connection before the page loads, which is why I've created this project. And my project will make sure that the browser does not even waste memory downloading the ad code. And every request that the user, like every request or every time the user is trying to go to a different URL, the command will be evaluated at the network level, not the page level. And this will give my project an advantage over other extension-based blockers. So then this slide is basically about how I'm creating an ad-free experience, because not only are ads annoying, they also take up battery and slow the user's operating device and track movement across the web. And my project eliminates this by integrating a trained AI model of malicious and non-malicious URLs from a vast database of known ad servers. And this is in the browser and like in the code for the browser to ensure that the users will have an ad-free experience. This is about the SecureSurf's threat defense mechanism. So it kind of happens in 3 steps. So first is the URL reputation check. And whenever the user is trying to navigate to a link, the trained AI model will cross-reference the destination URL with local threat intelligence databases, because that is where I'm getting my data from that I've used to train the AI model. And these databases contain known phishing domains and malware sites and other malicious endpoints. And this happens before the browser even attempts to connect, like I said earlier. And the second layer is real-time traffic inspection. So every network request is monitored and evaluated in real time by the Python firewall. And this also happens at the network layer and gives the app some visibility into traffic that the normal extension-based blockers cannot see. And then lastly, if a threat is detected, then the connection will be immediately terminated before the malicious page can even load or any payload of that sort can execute. So usually people, I feel like, think that with more security, it means that the application is going to be slower, but my program blocks malicious activity before it downloads. So that means it saves time and that the user's computers do not have to waste energy rendering heavy ads or running any background trackers. And then Another thing I noticed about other firewalls was that they have like these, scary broken error pages with a bunch of code on them that the user cannot usually interpret. Usually I have to take that and put it into, ChatGPT or Gemini to understand what's going on. So another one of my individual contributions was the user experience. So I designed a custom-friendly block page, and basically when SecureSurf stops a threat or notices that this URL is malicious, it does not just show an error code, it explains to you what happened and ensures that you are safe. So here it says the AI classifier flagged this page is likely malicious due to phishing, malware, or suspicious link. So if it was like, something else, it would say something differently to let the user know exactly what the problem is. And then this is just what's happening in the background. So I'm using a Chromium engine and also Python 3.12. And with my project, I was basically able to convert it from like a conceptual folder structure that me and my mentor were working on in the beginning of the project. And then I was able to convert it into a fully functional package Mac OS application. And just overall, I've solved the problem of invasive browsing, create an impact on faster and safer internet access for the user. And with the help of my mentor, I was able to take this project on. Right now, I'm only using like one trained AI model, but something that I could implement in the future would be like having a random forest classifier, which I know was talked about in the instructor-led sessions. And that's basically like when there's multiple AI models and individual decision trees, which I feel like I could have more data to make my model even more accurate, and I could implement that. But apart from that, that's it. That's my project. Thank you.
Awesome. So, do you have a demonstration of the project?
Yeah, I do. Um,
Okay.
can close this and I can open that up. Okay, can you see the browser page? Okay, so this is my CSV that I've used for my data. So this is the one denotes like a malicious URL and zero is non-malicious. So I'll just go ahead and copy this link and test it here. So like if this is a user and they're trying to go here, and I'll say, this is connection blocked. If I type in like some non-malicious URL, it'll let me go there. Can try another one. The same things, connection blocked if it's malicious.